Students, let's start with solution. So today I'm going to take some important questions of applications of trigonometry. So here few prove that questions are there which are not given in your NCERT textbook, but there can be the question which can be asked in different way. So let's have the revision so that if this kind of questions will be asked, you are able to appear. So generally you know how to solve and how to apply application of trigonometry. So the question is, a flagstaff of height h stands on the top of a school building. If the angle of elevation of top and bottom of the flagstaff have the measure alpha and beta from the point on the ground, prove that height of the building is h 10 beta upon 10 alpha minus 10 beta. So in your textbook questions are given related to the measurements. So here we are having in terms of 10a and 10b. So let's draw the figure for this. As it was given, there is a flagstaff on the building. So here a building is there. On the top of the building there is a flagstaff, and from a point on the ground, the angle of elevation of top and bottom, you need to follow out the sequence. Here the angle of top is given first, so top angle is alpha, and angle of the bottom is given beta, and height of the flagstaff is given h. So here angle of elevation of top and bottom of the flagstaff have the measure alpha and beta from a point on the ground. Prove that height of the building. This we need to prove. Height of the building, that is, if it is h, we need to prove h is equal to h 10 beta upon 10 alpha minus 10 beta. So let's start out with the solution. So here base is not given, so let me consider this to be x. So as usual, you go for the solution, start out in the same way, don't get confused. So for this kind of questions, you need to label it. So I'm starting with bigger triangle. In triangle ABC, as the angle C is alpha for triangle ABC, so 10 alpha is 10 is perpendicular upon base, so thus it is h plus capital H upon x. Let this be first equation. Now for triangle BDC, the smaller triangle, for smaller triangle angle is beta, so 10 beta is capital H upon x. Let this be second equation. Now we are going to find out the value of x from both the equations. From first equation, x will be h plus capital H upon 10 alpha, and the same way second equation, x is capital H upon 10 beta. From both the equations we got the value of x only, so we can compare them. From 1 and 2 we can make h plus capital H upon 10 alpha is equal to capital H upon 10 beta. Now replace them. So here to prove you can find out there is 10 alpha minus 10 beta. So here we are going to shift out this 10 alpha there and then h to be to the bottom, or we can have the cross multiplication. Now multiplied h 10 beta cross multiplication plus capital H 10 beta is equal to capital H 10 alpha. We'll be shifting capital H part towards one of the side as we need to find the capital H value. So 10 H beta is equal to capital H 10 alpha minus, now shifting this term towards right, so capital H 10 beta. H can be taken common, thus it is 10 alpha minus 10 beta. If you want to find out capital H, so this will be h 10 beta upon 10 alpha minus 10 beta. This is nothing but height of the building, so this only we need to prove. For such kind of solutions, questions, we need to find a solution in the same way as you are going for the regular questions, so don't get panic. So these are the simple questions which you can solve in the same way as you are solving rest of the questions of applications of trigonometry. Now the next question, a jet plane is at a vertical height h The angle of depression of two tanks on the horizontal are found to have alpha and beta. So here there is a plane and angle of depression is given. Though the depression is given, draw the angle in the same way. Angle of depression is given alpha and beta, and here the condition is given alpha is greater than beta. So as per this condition, this angle is alpha and this will consider beta. We need to prove that distance between the points h is h tan alpha minus tan beta upon tan alpha tan beta. So distance is nothing but this value. So this is our distance. So this we need to prove. So to prove, CD is equal to h tan alpha minus tan beta upon tan alpha tan beta. So let's start out how we will solve this question. So as depression is given, so whenever depression word will be there in the question, make one parallel line and complete this angle as alternate angle. So here it is alpha, so this whole will be alpha and the smaller one is beta. So let this part be beta. So let's start out with the solution here. In triangle ABC, so we'll consider some of the letters. Let this be x and y so that easily we can solve out. In triangle ABC, tan alpha is h upon x, and in triangle ABD, that is bigger triangle, tan beta is h upon x plus y. We need to find the value of y. So we are going to get the solution in terms of y. So here let's find out the value of x. Cross multiplication, h is x tan alpha. Let it be first equation. Now put out this value in equation number 1. Tan beta is equal to x upon tan alpha x plus y. Now have the cross multiplication for this term also. X tan beta plus y tan alpha or y tan beta is equal to x tan alpha. Now we need not to find the solution in terms of x. So let's shift this x towards left side. Now y tan beta is equal to x tan alpha minus x tan beta. I shifted this term as I need to find out y. So x can be taken from both of them. X is nothing but x value, x is tan alpha minus tan beta, y tan beta. So we need to get the solution in terms of h. So here y is x tan alpha minus tan beta upon tan beta. So we'll replace the value of x in first equation as already we had, where we need to get out the value of h. So here x is h upon tan alpha. Let it be third equation. Now put this value and the last solution which we got, we can replace x with h upon tan alpha. Already tan beta is there. Tan alpha minus tan beta. So in this way we can find out the solution. So how I started, once again I'm going to repeat. So let's start out with the first small triangle, triangle ABC, where I consider AB was given as h and this I considered x and y. We need to prove that this distance is h tan alpha minus tan beta upon tan alpha dot tan beta. So first, as usual, you start out in the same way. In triangle ABC, tan alpha is h upon x. We can have the cross multiplication where h is x tan alpha, and then finally we can find out the value x as h upon tan alpha. Now start out with the bigger triangle, triangle ABD, where tan beta is h upon x plus y. Now having again the cross multiplication, x tan beta plus y tan beta is equal to x tan alpha. Now shifted this x part towards right, then x is taken common from both of them. Then we got the value of y as x tan alpha minus tan beta upon tan beta. Now we can replace x as we need to prove the sum in terms of h. So I replaced x with h upon tan alpha, and then the rest of the whole equation was repeated as it is. So this is the final solution where we got distance CD as h tan alpha minus tan beta upon tan alpha dot tan beta. So this is only the solution. So whenever you are going to get this kind of questions, so as you are solving in the simple way, the same way you need to repeat. Now the next question, the angle of elevation of top of a tower from 2 points at a distance of A and B meter from the base on a same straight line are complementary to each other. So we need to prove that height of the tower. So here it is given complementary. So let's draw the diagram for this. So here 2 points are there which are at a distance of A and B. So let this point be at a distance of A and this complete point is at a distance of B. We need to prove height of the tower. So this h as root AB, this we need to prove. This can be MCQ also. Remember that whenever the angles are given complementary. So as it is given complementary means sum of the two angles is 90. So if I consider one as theta, other will be 90 minus theta. Now out of this triangle, we need to prove that this height is under root AB. So let's start out with the solution. Tan theta. So as I consider tan theta, so this is the bigger triangle. In triangle ABD, tan theta is h upon B base. Let this be first equation. Now in triangle, the smaller one, triangle ABC, tan 90 minus theta is h upon A. Let this be second equation. So already you are familiar with the formula. Tan 90 minus theta is cot theta. This exercise was there in CBSE syllabus before this last year, but they removed this 90 minus theta type of sums. So here 90 minus theta is cot theta. This you need to remember. Now to get the solution, we need to multiply both the equations. Multiply equation 1 and 2. So that's our final solution. If you multiply both the equations, tan theta and cot theta, it's h upon B multiplied by h upon A. Tan and cot both are reciprocal to each other, so they get cancelled and it's 1. And here it is h multiplied by h is h square upon AB. Having cross multiplication, h square is AB where h is root over AB. Same question you are having in your exercise also. Last question where they have given the distance as 4 and 9. We need to prove that height is 6. So as the distance was given 4 and 9, so here we are having root of that 4 multiplied by 9, which is 36. So we'll get height as 6. So this kind of question they can ask either in MCQ form or directly prove that. So this is also one of the simple question where you can solve very easily. So this type of questions are very important, which are often asked. So once you go through with the solutions.